Hello everyone, I am Thorsten Hempel and I am presenting our new work, NITEC, Versatile Hand-Annotated Eye Contact Dataset for Ego-Vision Interaction. And this is a joint work with Magnus, Ahmed and Ayoub. Eye contact is a fundamental nonverbal interaction cue, and humans are very sensitive in detecting it. However, in human-machine interactions, for example with humanoid robots, this interaction level is largely unexplored. We argue that one of the main reasons is the lack of datasets that are big and qualitative enough to train end-to-end models. We tackle this challenge by creating a new dataset called NITEC. NITEC is based on the data from multiple public datasets to increase the diversity and variability. The chosen datasets are Helen, Celeb A, Gaze 360 and Wider Phase. In total, there are almost 36,000 samples in the dataset, where 29,000 are in the training set and the rest in the test set. For the samples in the training set, each sample is hand annotated by a single annotator, where for the samples in the test set, each sample is hand annotated by 3 annotators, where the final label is chosen by majority votes. This way we want to make sure that the labels are high quality. On this slide, we see a general comparison between our dataset and two other datasets for ego-vision eye contact. There is the OFDIW and the DPEC dataset, which are also public. On the left figure, we see a general comparison of the sample size, also including the split of our dataset with the subsets. And we can see that our dataset is by far the biggest one, with more than double the size of OFDIW. On the right side, there's also the split of the label distribution between no eye contact and eye contact. And we can see that the NITEC dataset provides a roughly equal distribution between eye contact and no eye contact, where the second largest dataset, OFDIW, has a large oversize of no eye contacts. To evaluate our dataset, we trained baseline models, which are the ResNet 18, ResNet 50, and Spin Transformer models, and tested the models on the other datasets and the test sets. And we did the same for the DPEC models, or for the DPEC dataset, and also for the OFDIW dataset. Also, we choose some head pose models and gaze models to evaluate if these models also are capable to detect eye contact. And in this table, we see the results from the models, and we can see that the highest accuracy and the highest F1 scores are achieved by the models that are trained on the NITEC dataset. Even on the cross-datasets evaluation, we see on the test set from DPEC and the test set of OFDIW. This slide shows further qualitative results to analyze the classification behavior of 3 different models. The NITEC model, the Jung et al. Model, which is based on a dataset with 2 million samples, but not public, and the gaze model. All 3 models are applied on the data of the MPII face gaze dataset, and the prediction results are compared to the ground truth that is provided with the dataset. The figures show the prediction confidences in colors from high confidence, blue, which means eye contact, to low confidence, red, no eye contact. And we can see that the predictions of the gaze model are very noisy and inconsistent, while the Jung model and the NITEC model provide a clear confidence maximum near the center of the camera. Noteworthy is not exact the center of the camera, but slightly below it. As this behavior applies to both models, the Jung and the NITEC model, which are independently trained, the reason could be found in the annotations of the training dataset, where a gaze target on the face also below the eyes would be perceived as eye contact. This slide provides additional qualitative results to compare the NITEC model, the Jung et al. Model, the OFDIW based model, and the gaze model L2CSNet. For the gaze model, we can see that it predominantly tends to create false negatives. This is especially evident in the first row, where all of the eye contact faces are falsely classified. On the other hand, the Jung et al. Model tends to create more false positives, shown in the third row, whereas the NITEC model provides the most balanced predictions. To evaluate how the models trained on our dataset perform in real-world scenarios, we conducted an initial user study, and in this study, a humanoid robot performed simple interactions with 9 different subjects. And the interactions were recorded from the robot's perspective and afterwards hand annotated for eye contact. As a result, we generated additional almost 6,000 samples from a challenging real-world interaction scenario. And in the initial experiments, the NITEC model achieves an accuracy of almost 80%. In summary, we publish a new dataset for ego vision eye contact classification called NITEC, with almost 36,000 hand annotated labels, including almost 7,000 in a test set where each sample was labeled with 3 different annotators, providing excellent quality. The dataset surpasses all other public available datasets in size, variety, and label quality. And we demonstrate its quality by training and testing multiple baseline models, providing state-of-the-art results. We also conducted an initial real-world study showing that the NITEC model is able to generalize in the real-world scenarios. The dataset, a demo, and some additional scripts are made public on GitHub. If you're interested, check out the link or scan the QR code on the bottom of the slide. Thank you very much.